ASMR video. For this video, I'll be coding a program that multiplies two matrices together to form a new matrix. So, there's going to be some chapters along this video where it's going to be easier to follow. You can click on the timeline in the video to see where you want to look at. So, enjoy. So this is the program where I've left off from my previous video. If you have not seen this video, there is a link in the description where you add two matrices. And I am going where I've left off of this program. So this is the matrix program I've left off. I made some small changes. Instead of integer arrays, I'm gonna do double arrays so that I would allow decimals to be placed, to be calculated. So, whereas in integers, I can have decimals. So now, let's begin this method, shall we? So now, I have these two methods that add and subtract. Now I'm gonna make a method that multiplies matrix A and matrix B together to form a new matrix. Alright, so let's begin. Public static double array. By the way, matrices in Java, they are denoted into the arrays. So the 2D arrays are represented, or what represents the 2D matrix. So multiply, self-explanatory, matrix A and B, in which I will input double. No, can't even spell, type double. A, let's just do this, copy paste that, and yeah, input two matrices. And what I'll do is I will return a matrix at the end after this method, which is the resultant matrix. And yeah, so before we even start multiplying, we have to check, you have to make sure that you can multiply, you can even multiply these matrices. So to know whether we are able to multiply a matrix, the two matrices must follow the condition. So the number of rows in matrix A must be equal to the number of columns of matrix B. So, and I'll check this in an if condition. If A dot length, just add the length property here of the first matrix is literally how many rows this matrix has. So if A dot length is like 4, that means it has 4 rows. If I check if this is equal to B, I'll take in the first index, considering that the first index is a subarray, and take the length property of the first index of B. Alright, never mind. I'm gonna explain this differently. If the B at the 0 index represents an inner array, and you take the length, represents how many values are inside the subarray, that would equate to the number of columns in the matrix. So that assumes that the arrays are rectangular, meaning that the rows each subarray has the same number of entries, which I will mention shortly. So this, if the number of rows in matrix A is equal to the number of columns in matrix B, I will proceed. Wait, let's just test the opposite. If it's not equal, then I'll print an error. Error. Cannot multiply these arrays, matrices, given that their dimensions, based on their dimensions. The faster I type, the more likely I'll make a mistake. So yeah, and yeah, that's a condition. And also, I'm just going to copy this here. This condition, I've added this condition. I didn't, and this like outside of a video as a adjustment because the matrices have to be rectangular. So I pre-test this out that the matrices, both matrices, arrays in this case, must be rectangular, or else I cannot proceed to this code. So I'm gonna copy this and put it here. So to first test this out. So yeah. So these are just validation code. I know validation is boring, but it's kind of important that you need to have validation, or else like so that you have correct inputs. Just putting a comment here. Alright, so yeah, let's begin. Validation gone. Now, well, the validation out of the way, let's code now. So, in order to multiply the matrix, we need to wait, I forgot something. The number of columns, it's not rows, it's columns. So like if a 2 by 3, like a 3 by 2 in this case, if you do that, if you do like if you multiply 3 by 2 by 2 by 3, you should get these inner numbers must be equal. That's how I look at it. So the number of columns in matrix A must be the number of rows in matrix B, I guess. So let's just take B dot length and do a index 0. So you access the column, the number of columns in reverse. So just like flip that. Or I could just switch the letters, but yeah, I did it the hard way. So this can multiply, but can't multiply because the number of columns of the first one, the left one, is not equal to that. So now, with this error out of the way, let's proceed to the code. So now what we'll do is we'll make a new empty matrix, resulting matrix, let's call that, because they have the same name, resulting matrix. outside numbers, the outer numbers. So if you multiply 3 by 2 by 2 by 3, you'll get a 3 by 3. Alright, so that's new. Let's add it, let's do the double. We're creating a new empty double matrix, and we have to specify the number of rows, which will be a dot length. And we're gonna create p dot length. P at I dot length. Yeah, p dot 0. Assuming now that the first row, we just take the first subarray, take the length, and now we know how many columns. We will know the columns, how many columns our matrix, resulting matrix will be, just to specify. So yeah, so this is the number of columns our resulting matrix will be. And now we multiply. So we will use a for loop. Alright, so before we kind of multiply, I'm gonna try to print two matrices together. So I have created a 2 by 3, and let's erase this for now. I created a 2 by 3 and a 3 by 2, and now I'm gonna print these matrices. Whoops, I did not return this, but let's just do a void. Let's return a void for now because I did not complete my method. And comment that out. We got like a 2 by 3, 2 rows and 3 column matrix, as well as a 3 by 2 row 3 row by 2 column matrix. So if we multiply a 2 by 3 by 3 by 2, we will get a 2 by 2. So how we multiply matrices is I will take my ideas. I will take the first row and the first column, the first row of matrix B, and the second row of matrix B to get the result of the first row and the first column. So it's like a dot product. I multiply this by that. I multiply 1 by 7, first row, the first entry of that A, and the first entry of this column, and then I add 2 plus 9, and then I add 3 plus 11. So it's like a dot product of the rows and then the columns. And then if I want to find the second entry of the first matrix, of the resultant matrix, I'll then take the dot product of this row and then this column. So like 1 plus 8 plus 2 plus 10 plus 3 plus 12. It's kind of hard to explain in general terms, but that's how I'll try to do. So I'm gonna go attempt this loop to perform this operation. So let's do a for loop. Let's call it J, because I think I'll see it as a for loop because we want to multiply 2 entries. We want to get fill out these 2 by 2 matrix. So we start at 0, I guess. We iterate till it reaches let's do a dot length, and I will try to do a dot product. Keep in mind that I am coding this from scratch. This little method, in this case, I've coded the other methods in So I would have to take, if I want to multiply 1 by 7, I'll have to take A, access the first row, which is 0, and access the 0th column. So, and I multiply that by B at the first row, 0 and 0th column. So yeah, I'm gonna then take, and then I'll have to add 2 by 9. So which is like A, X is the first row, the first row still, and the first column. And then you times that by B, but where you access the first, the second column, the second row I mean, and then the first column. By the way, my explanations aren't that great. This code that you see here is not the final code. I'm trying to see a pattern here. And then you take, don't like to multiply 3 by 11, which is you take the A and then X the first row still, but the second column, the third column, I got mixed up with the indices. And you times that by B, that, and you times that by B, at the second, the third row, which is 2, and then still the 0th column, the first column, which is column 0 in this index. When it comes to indices, bear in mind this is like a pretty long step, and I have to really think a lot before I proceed. And this is where I'm working with nested loops. And so yeah, I am trying to find a pattern here. So if you want to skip ahead to the next chapter, the later part of the video, there's these chapters that I added, so you can skip ahead to where I start running the code. But if you're really interested, you can try to watch me try to figure out me coding it. So if you're bored, just like I'm saying, if you're bored, you can just skip ahead. So I am now, this is like doing the first entry, and then I just try to do the second entry. Oops, I forgot here. So this is, and I try to do this, and I have to multiply this, I have to, now in here, this is what I didn't do, in this line here, I'm going to keep the first row, but take the second column. If I want to find the matrix entry, for a first row, but at the second column. So in order to find it, I have to take this row and this row, this column and B, this row for matrix A, and this column for matrix B. So I'm taking the dot product. Alright, this is a pretty long process. Okay, so I'll have to do a dot product of this and that. So I have to first multiply 1 by 8, so I take 0, that's 0. And then I have to do, I'll have to do 0 to 1 times 8, so 0 matrix A, 0 times 0, first row, first column, times B at B, the first row but at the second column, Okay, first first row, which is 0 at the second column. And I am gonna try and continue on, and then I have to do times it by, add by, I have to add 2 by 10, so for matrix A that means accessing the first row, but at the second column, I guess, and times it by, no, 2, yeah, multiply 2 by 10, so that is B11, I guess, and then C, and then the last one is just, which is like 3 times 12, so that means to access 3, I will do a 1, no, still in the first row, but at that, this stays the same by the way, and, but B, for B, this access, to access 12, I have to access the third row, which is 2, and put 2, because third row and second column. Oh yeah, it's 1 because third row, second column. Alright, so keep in mind here that I'm going to compare these two lines. So for the first time I run, I have to do, this will be 0, 0. It stays at 0 here. And then this one, this index, the second one just changes. So I am slowly trying to figure out this problem. So sorry that this becomes really, really long. If you really want to see me test a code, you can fast forward. I put these chapters, so, but if you want to hang on to this coding process, you can, and I'll still give you some more tingles. So as you can see, the inner indices change as I multiply. So that could be in a loop. So let's do this. It's J equals 0. J will be equal to, no, J will equal to, J is less than a dot length, because here I will always multiply, do the dot product from 1 to 3 up to the a dot length. So I'll use that because here, when I do this and I do this, this basically, this loop basically calculates a dot product of an entry, and I do J++, and this resulting matrix, I will, these ones always add, always adds the J here, plus J. I'm gonna keep these ones here because, no, keep it here just as a template because eventually I'll have to change it. So these inner values always change. They change as I try to calculate the dot product. So I just do plus J, then plus J. So keeping in mind that line here, this basically calculates for the second row of the second column of the first row of the resulting matrix. Keep in mind that it's a 2 by 2 matrix. The result is a 2 by 2 matrix. Keep in mind that the result is a 2 by 2 matrix. So what's changing here apart from the inner values? So these inner values are changing. That's figured out in this for loop here. So this is the first resulting matrix here, 1. I forgot that was a mistake. So putting the result at the 0, the first row in the second column. I keep getting mixed up with the entries because starting at 0 meaning like I keep saying the 0th row. So yeah, I have to now take 1 times 2 by 3, keep it here, but this changes here. P that 0 to 1, and then P that 1 1, and P to 1 2. P. I think I made a mistake here. I tried to multiply 3 times 12, so A 0 first row, third column, times it by third row 2, second column. I'm trying to differentiate these. Okay, now I think I figure out a pattern here. I compared these lines before, these entries, these additions, but I have to compare this first row and the second line here, because what's changing is it changes from 0 to 1. So in this hour loop, basically what's changing is the values at the columns here for the P. So I do int K, the outer for loop, and I would do K as long as K is less than we want to do loop to the resulting matrix dot length, because that's how we fill out the row of the matrix. The row is equal to the column. No, the column, the length of the column, because this basically fills out a subarray, meaning one row. So iterate K up to the number of columns, so that the columns get filled up into one row, and K plus plus every time. And here I just have to copy paste this here inside this so it's nested. Okay, so yeah, calculates the dot product of an entry. So whoops, I closed this window. I'm gonna reprint that. Okay, so I will now figure out how I can start it here. So I start at K, right? No. I start at 0. But yeah, I think I have to use K because these numbers have to change. So it's 0 plus k plus k here. Like that. The best thing is that I think I don't have to calculate anything and put any statements in the outer loops. I just have to adjust the statement inside the inner for loop. Now I'm slowly cracking things up. So yeah, this outer loop, one entries in one row, basically here in this inner for loop for a dot product of this array. So yeah, and then now I can imagine I have to iterate to all of the rows, so I have to do another outer loop. So I have to now do an outer loop, so to loop to the entire matrix. Keep in mind that this outer loop only calculates the entries in one row for the resulting matrix. So even outer loop that calculates all entries, calculates the entire matrix throughout all entire rows. Okay. So now I could do for int I equals 0. I is less than their matrix, the outer, the resulting matrix. Belt length. We're looking at number of rows here in the resulting matrix because that's what we want. This even outer loop is for all of the rows that we're trying to calculate, which contains these inner for loops. Alright, and I plus plus. And now I have to just copy and paste it here. So bad indentation, just put it here. I think I should have created a helper method, but for this video it's going to be really hard to do it while talking, so I might have to refactor this along the way. I might have to refactor this outside of the video, but yeah. So for here I will just have to I guess, why did I create it here? I messed something up. I should have not put it here because these ones are already in this loop, so I don't have to do this. I'll just redo this and put this here. This is not the final code here. This is just here for the pattern. And copy and paste, so yeah, like that. So what's changing here is I'll now have to change these. So it kind of makes sense. So this was not changing because this is like the number of rows. Because in the dot product, if I want to, hold on, and then subsequent iterations, I will have to take the following rows. So now, and this subsequent, and all other iterations, this first index will change 0 plus I, because each index in the most outer for loop will shift through the rows of the first matrix, and K is just this inner for loop which shifts through the columns, I guess. And J here is just like doing the dot product thing. Alright, now, and I have to change the return type to also this has to change. I and J. So I can imagine I and J both start at 0. And K is the one I have to do. So K, not J. K is like the iterator for this inner for loop. And I is the one for the rows, which is the outer for loop. Alright, I'm gonna test it. Do like a rough test to see how I am going. So now as I have these matrices printed out, let's see if I multiply them. Let's see if I call this method to multiply A and B, matrix A and B. If I would call that, I will see. I guess I will test if there's an error. So I'm gonna put like a printout statement. To add a print line statement here, so just to tell me that the program does not run into a runtime error. So line reached, code reached. So if this is reached, that means these for loops executed well. And I did not test the method before, which is not a good thing. I should have done it, but I do not know how I could test it intermittently without like testing and finished code. So let's see if I would do it here. So I'm gonna create a double like that. Since this method returns a double array, I would do result multiply, and I'll print that. Print matrix result multiplied, and we do A times B equals, and I'll print that. So I have these two matrices. I have these rows, the 2 by 3 and a 3 by 2, and I have this matrix as a result. A times B equals that. So let's see if that matches my expectations. Moment of truth. Moment of truth. I guess it did not work. So there's some mistake that I made somewhere. At least we got a 2 by 2. That's the good part. So we have gotten A392, which is so different than the one we expect. Okay, so I finally found my mistake. I realized that I haven't deleted these lines of code which contributed to the matrix. So my mistake wasn't in the for loop, it was in the part here before that I forgot to delete. Like I said, a lot of these mistakes come from stupid reasons. So, and also I forgot to put A to I, because if I just would do this, this would just loop until the length of the array of itself, the length of the big matrix, which would just basically loop till the number of rows. But here we just want to loop until the number of columns here. So, and I put this random if statement just because I wanted to see how many iterations this ran, how many iterations it did. So it did not. That if statement was random for testing. So put a.I, so it iterates until the row, the number of entries in one subarray, which is like the number of columns. So a.I.length, number of columns. If I do a without the I, that means the number of rows in the matrix. So in the dot product, we just want to loop. We just take the first array, the first matrix, and iterate till the length of that. So as you can see, if I would multiply A and B, I get 58, 64, 139, 154, which is what we expect. So multiplying that should expect that, and I happen to get this. That's magic. This is pretty magic. Although this required a 3-nested loop, a triple nested for loop, level 3, which I should have made this in a better way. I should have created a helper method, but it won't be in this video. I happen to successfully do it for at least a 2x2. Now, let's try a matrix. Let's try these ones. Square matrix along with an inverse. So I've created two matrices. I've created two other matrices that are 2x2s, which is one is a square matrix A, and the inverse. If you do not know, matrices they can also have an invert, in which if we multiply that by its inverse, we will get an identity matrix, which is like a matrix of all ones and zeros. And now I'll try to multiply these two together. So I know this will expected. This expects 1, 0 like that, and 0, 1, because if I would do A times its inverse, I'll get this. And I got this online. I got these values online, so I did not calculate the inverse. And now let's try to multiply these by A and B like that. A and inverse. So I'm trying to multiply these ones. Square matrix. Let's see how we will end up. Ouch. This is not what we wanted. We want to multiply. We will multiply these square matrix A and square matrix inverse. I forgot to do that. Let's see if I multiply this. I'm gonna try it now. What the hell? What just happened? Okay. That is very, very bizarre. So you can see, we got these weird values. And I'll just do like an extra method here. So I'm doing an extra method, private. I'm not gonna write a method, but let's see how this works. But this is what we get. We get these weird values. And this is like almost 0, and this one is almost a 0, and this is really close to 1. I do not know why this causes this, but this is pretty much almost resembling an identity, because this should have been 0, but this should have been 0. So let's just say that these are all zeros. essentially these values are really close to 0. And these values are really close to 1. So now if I try to do, I'm gonna try to do these matrices. Let's try these ones. These are 3 by 3 matrices. B, like that, and B inverse. And I'm just gonna multiply that by that. B and B inverse. If I try to multiply that, let's see how it works. I almost got an identity matrix except for this imposter here. So I try to multiply this by its inverse and get an identity matrix. This is so pretty cool, right? Except for this weird value. Alright, so as you can see, I guess I've kind of successfully coded a program, a method that multiplies 2 matrices such as that they are in equal size. And let's just determine if they're not in equal size here. It would give an error, but yeah, this will be the end of this video. I hope this gives you the tingles. This is a pretty long video, to be honest, just because this method was way harder to code than the other videos. And so, stay tuned for the next ASMR video. Maybe some more matrices, I'm not too sure, but yeah. So, have a good day everyone, and have a good night if it's nighttime, and peace out.